Good morning, AOBI. This is Mr. Dunning. Stand by. I have a math lesson for you. Today's lesson is going to discuss parabolas. We're going to take a look at the shape, the uses of parabolas in math, the equation of a parabola, what the graph looks like, and we'll use a few examples along the way. I think you're going to enjoy it. Our first stop in this lecture is the shape. And a parabola, like the things we have been studying so far, a circle and an ellipse, is a conic section. Now our cutting plane is going to be parallel to a side of the cone. Let's see how that works. Now, this isn't going to be perfect, but close enough so that you can see what's going on. I tried to make the cut parallel to a side, and the shape that we get is a frown, or if this is the cone we're looking at, a smile. So a parabola is either going to be a frowny face or a smiley face. It's a conic section that we get when the cutting plane is parallel to the side of the cone or the edge of the cone. In mathematics, we use parabolas to describe motion. Almost anything that we shoot or fire into the air describes the arc of a parabola. This is very useful. It describes the motion of rockets. It describes the motion of bullets that you fire. It describes motion. Okay? If you got really, really frustrated and were on top of a building and you threw your book into the air, guess what? Your book is going to follow the arc of a parabola. So we use parabolas to describe motion. But they're also very useful in describing real life situations of other kinds. We're going to see some examples of that. In fact, your quiz is going to give you a couple of problems where you have to solve real life problems using parabolas. The general form of the equation of a parabola is y equals ax squared plus bx plus c. Let me write that. Y equals ax squared plus bx plus c. Now each one of these letters, the A, B, and C, have a meaning, and we're going to talk about those in just a moment. The graph of a parabola, this is a smiley face parabola on the x, y axis system. Smiley face, someplace on the x, y axis system. Someplace. But we know a lot more than that. And that leads us into what A, B, and C do to move this shape around. So let's look at each one, beginning with C. When x is 0, you're someplace on the y-axis, okay? If x is 0, ax squared is 0, and bx is 0, so C is the y-intercept. The y-intercept has the coordinates 0, C. There, the y-intercept. So you can see the y-intercept right off. Now, just think about this for a moment. Half a moment. If C is bigger, the y-intercept is going that way. If it's smaller or negative, it's going that way. So the C term has the effect of moving the parabola up or down. Okay? Up or down. The C term moves the shape up or down. The B term, take a guess. It moves the shape right or left. So when we look at the equation, we can tell a great deal about where this parabola is located on the graph. The A term is going to describe the steepness of our parabola. So if the sides are really steep, A is quite large. If the sides are not so steep, A is smaller, and it can get very, very small. For instance, if you look at the wires stretched between poles, that shape has a very, very small curve. Some, on the other hand, are very steep. So the steepness of the shape, much like a slope in a straight line, is A. Okay? A. Quick review of what we have learned. The shape of a parabola is a smiley face or a frowny face. Parabola is a conic section gotten by cutting the cone parallel to an edge. That will create either a smiley face with this half of the cone or a frowny face with the bottom half of the cone. A parabola describes motion and energy. Remember this guy Einstein? He said E, that's energy, equals M, that's mass, times c squared. E equals mc squared. Well, guess what? E equals mc squared is the equation of a parabola. Conic section, yes. Describes motion and energy. And it solves many real-life problems. The equation y equals ax squared plus bx plus c. And each one of those terms, a, b, and c, have a meaning. We learned those. A shows the steepness of the sides. Here, parabola, steep sides, big A. Shallow sides, small a. B has the effect of moving the parabola on the graph either that way or that way. And C takes the parabola either up or down. So, looking at the equation, we can determine a lot about a parabola. Let's do a few questions and see if this sunk in. In this question, I want for you to tell me what's going on here when we do this. Well, if you've been following, B is 0, there's no x term, so the parabola is right on the y-axis. And there's no C, so it goes through the origin, the y-intercept is 0. Happy little smiling face, y-intercept right there at 0. Okay, so what happened here? Think about it. What happened? Well, this shape got moved up 1. Y equals x squared. Y equals x squared plus 1. Again, in both examples, B is 0. So there's no shift this way or that way. That means the parabola is on a y-axis. I'll give you another question. In your second problem, we begin with the basic shape of y equals x squared. Happy little smiley face parabola, y-intercept at 0. Now the y-intercept on both of these is at 0, so what's going on? Well, the B is 0, so there's no shift that way or that way. What is happening? Well, A is 3 in this example. That's going to make our parabola much steeper, like that. Here, A is 1/5. That's going to make our parabola very shallow, like that. So A determines the steepness of the shape. It functions in that way a lot like a slope in a straight line. If this is big, the sides are steep. If it's small, the sides are very shallow. We'll do a couple more problems so that you can see how B works, but you'll need some background in order to make sense of that. To solve a parabola means to find the zeros. That means the places where it touches or crosses the x-axis. Here we have the smiley face parabola, and that is a place it crosses the x-axis. That is a place it crosses the x-axis. Those are solutions or zeros. Now think about that. If we are looking for places on the x-axis, how big is y? 0. That's why these little puppies are called zeros. And we find them by setting y equal to 0 and solving the equation. Right there. We set y equal to 0 and solve that. Now we're not going to do that today, but we will do it tomorrow, and it's going to take us a little while to get there. So tomorrow is going to be a long day. We're going to go through how you solve a quadratic equation. As always, you've been a fantastic audience. You've learned a heck of a lot about these things. I hope you have a fantastic Tuesday night. School is almost over, but this class is not over. So hang in there. You're going to learn about parabolas, and I think you're going to really enjoy it.